Hello juniors, today we're going to be working with the sine rule, which is a topic that you told me that you have seen already last year. But today the idea is for me to show you where this formula comes from and then try to see some real IB exam style questions about this particular topic, okay? So this is also part of the IB program, that's why we're going to be reviewing this topic. So the sine rule. Objectives: find the length side of scalene triangles, find measures of angles in scalene triangles, and recognize ambiguous case for sine rule. Okay, so first of all, we're going to do a demonstration of where this formula comes from, okay? So let's consider an scalene triangle. Remember, a scalene triangle is a triangle that has all of the sides and angles are different, right? So this formula for the sine rule is really useful because it is applicable to any type of triangle, just as we did last class where we demonstrated the formula for the area of any triangle. We're also going to apply this formula of sine rule to any triangle, right? So that's the usefulness of this formula that we're going to be looking at today. So considering this triangle, once again, I'm going to do the same thing I did for last class where we demonstrated the formula for area. I'm going to consider this scalene triangle and I'm going to trace the height of this triangle if I consider side C to be the base of this triangle. So this would be the height of the triangle. And by doing this, you see that I get two right angle triangles, right? So I can apply SOHCAHTOA to these two particular triangles. If I call this side, this intersection here, I'm going to call this D. You see that we get two triangles, the ADC and CDB, right? Two triangles, two right angle triangles. So by working with those two right angle triangles, we can say that, for example, if we look at triangle ACD, the small one, the one right here, right? The ACD triangle, we can say that, for example, sine of angle A is opposite H over hypotenuse, B. The hypotenuse of this triangle is B, right? So by solving for H, leaving the H alone, I can have that H is equal to B times sine of A. Now, if we look at another triangle, for example, this triangle over here, which is triangle BCD triangle. From this triangle, we could say something similar. We could say that sine of angle B, of this angle over here, is opposite H over hypotenuse, which is A, right? So sine of B is H over A. So by solving for H, we're going to have that H is equal to A times sine of angle B. And you see that in this expression, we have H alone. I'm going to write this expression number 1. And here I also have H alone. I'm going to call this expression number 2. So since I have H and H here, then I can equate both equations, right? I can say that equation 1 is equal to equation 2 because we're talking about H in both cases. And by doing that, I'm going to get the following. I'm going to get that B times sine of angle A is equal to A times sine of B. And then if we reorganize terms, we're going to get the sine rule, which you're going to remember. For example, if I take this sine of A dividing here and this sine of B dividing here, I'm going to get the following. I'm going to get that B over sine B, sine of angle B, is equal to A divided by sine of angle A. And this is exactly the sine rule formula. Okay, so this is where it comes from. You see that it's very easy to demonstrate where it comes from. So let's scroll down here. It says the sine rule. For any triangle ABC, where A is the length of the side opposite to angle A, B is the length of the side opposite to angle B, and C is the length of the side opposite to angle C, then this is the sine rule, right? Sine of A divided by A is equal to sine of B divided by B equal to sine of C divided by C. Or we could flip the order of this, numerator and denominator, and we're going to get this formula. A over sine A equals B over sine B equals C over sine C. And this is what we know as the sine rule, okay? It says this formula is given in the formula booklet that you use in the examination. So you don't need to memorize this formula. It's in the formula booklet. You can use the sine rule to solve triangles if you know the size of at least one angle and its opposite side, and one other element, the length of a side or the size of an angle. So this is the rule for applying sine rule. We should have at least two informations of one same letter. That means we should have angle A and side A, for example. And then any other piece of information. It could be either, I don't know, angle B or maybe side C. If we have any other third piece of information, then we can apply sine rule to solve all of the rest of the triangle. So that's the rule for applying the sine rule. Okay, so let's see an example about this. It says, find the missing angles and sides in this triangle, giving your answers to three significant figures. So what do we have in this situation? We have angle A and we have side A. And then we have side B, right? The one opposite to angle B. So we have two pieces of information from the same data and one different piece of information, in this case side B. So as I meet the condition of the sine rule, I can apply sine rule to solve this triangle. So I'm gonna do exactly that. I'm gonna apply sine rule, the sine rule formula. So the sine rule says that A over sine of A, so 12, which is side A, over sine of 98 degrees must be equal to B, which is 9.4, over sine of angle B. So with this, I can solve for B, find the angle B, right? We're going to solve this with the help of the calculator. We're going to say that sine of B, sine of angle B, is equal to, if I take all of this, it's 9.4 times sine of 98 degrees, and this is being divided by 12. So with the help of the calculator, we're gonna solve this. Remember, we would also have to do shift sine of all of that to get the final angle, which should give us, if you do this in the calculator, you should get 50.9 degrees. Okay, so this is the measure of angle B. So we have our first piece of information found. We know that this angle over here should be 50.9 degrees. Then, if I want to find this angle over here, I could, if I want, I could apply the sine rule again, but I'm going to waste too much time. There's another shorter step, which is basically, if I already have this angle and I have this angle, I know that the sum of the angles in any triangle is always equal to 180 degrees. So we can say that 180 degrees is equal to 50.9 degrees plus 98 degrees plus angle C. And by solving this, we're going to get the value of angle C, which would be equal to 31.1 degrees, if you do this in the calculator. Okay, so we already have measure of angle C, and the only thing we're missing, let me write this, 31.1 degrees. So the only thing we're missing is side C. To find side C, here I will have to apply sine rule again. Or we could apply cosine rule, but since we still haven't studied that, we're going to apply sine rule again. And we're going to say that, for example, side C, which I'm looking for, is as to sine of 31.1 degrees, as A is to sine of A, sine of 98 degrees. So I solve this, and we get the value of C. In this case, C would be equal to 12 times sine of 31.1 degrees. All of this is being divided by sine of 98 degrees. So we solve this, and we'll get the value of C, which would be equal to 6.26. We're talking about centimeters in this case, centimeters. So there you go. We solve the whole triangle. Solving the whole triangle implies finding all the missing sides and angles of the triangle. So we solve this complete triangle using sine rule only. So then it says, this is very important. Here you have a summary of what we just found here. This is the same triangle we just solved. And this is very important. Always check your final answers to be sure the shortest side is opposite the smallest angle and the longest side is opposite the largest angle. So that's a quick way to check your result. You see that, for example, this angle 98 is the largest one between the other two angles, right? Oh, in between the three angles, actually. So it means that opposite to this angle, we should have the longest side. And if you compare the side, this is 12, 9.4, and this C is 6.26. That means that this is correct, right? Opposite to the largest angle must be the largest side. And also opposite to the smallest angle, in this case, 31.1, should be the shortest side, which is also true for this situation. So that's a quick way to check if you're doing the right thing. If you get, for example, this side as the largest one, then you should automatically recognize that something must be wrong, okay? So that's a quick way to check your result. Now let's move on to this example. It says, find the missing angles and sides in this triangle, rounding your answer to 2 decimal places. So we're going to do the same thing, but now with this triangle and this information we have here. We have angle B and side B. That means that we will be able to apply sine rule. And then we also have, as an additional data, angle C. So the first thing I see that we could do is start by finding the missing angle, right? If we already know this one and this one, we know that angle A must be 180 minus the addition of those two, right? So we're going to say that angle A is 180 minus the addition of 77 plus 39 degrees in this case. So there we get angle A, which would be equal to 64 degrees. So that's a quick way to start this problem by finding that missing angle. This is 64 degrees. Okay, so we're missing now side A, side C. We can find any of those by applying sine rule. For example, if we want to find, let's say, side A, we're going to say that A is to sine of angle A, sine of 64 degrees, as, and we're going to use the pair of value we already have the information of, B, which is 40.5, divided by sine of B, sine of 77 degrees, okay? So we solve for A, we leave the A alone, and we will get a value of 37.35 if we round this to 2 decimal places. 37.35 centimeters. So this is a value of side A. Finally, I am missing side C. In order to find side C, I could again apply sine rule and say that, for example, side C is to sine of angle C, which is 39 degrees, as B, 40.5, is to sine of angle B, sine of 77 degrees. So then if we solve for C, we're going to get the value of C, which is 26.15 if we round this to 3 significant figures. Okay? So you see that this is quite easy, right? If you know when to apply sine rule, then this is very easy. Let's see one last example, which is the following. It says, a ship is sailing due north. The captain sees a lighthouse 10 kilometers away on a bearing of 32 degrees. So here, once again, we have the concept of bearing. You should remember what that is about. Okay, so it says, later, the captain observes that the bearing of the lighthouse is 132 degrees. How far did the ship travel between these two observations? So, The hardest part of this problem is actually doing the sketch of the situation, okay? You should really understand what is happening here and most importantly, the concept of bearing in order to correctly do the sketch. If you do the sketch correctly, then solving the problem would be much easier. But there's a challenge, doing the correct sketch. So first thing, the ship is sailing due north. That means that it is always going north. Okay. So let's say that the ship is initially right here, for example. Let's say this is the initial position of the ship. And it says, the captain sees a lighthouse 10 kilometers away on a bearing of 32 degrees. If you remember the concept of bearing always, to do a bearing, we always start north, right? We go north, and then if we go in a clockwise direction, we're going to mark this angle, which is 32 degrees from the north, okay? So from north, we're going to trace 32 degrees, which should be something like that, maybe. That's 32 degrees. So that is a direction in which the boat is looking at the lighthouse, which we could put somewhere there, for example, right? We could say that in this position is the lighthouse, which obviously does not move. The ship is the only one moving here. And the distance of that bearing is of 10 kilometers. So the bearing is 32 degrees. That means that this is 32 degrees right here. Okay, so we have done the first part of the problem. Then it says, later, the captain observes that the bearing of the lighthouse is 132 degrees. If you remember, 132 degrees, if we start north, 132 degrees would be, this is 90 degrees, and then it will be in the second quadrant, right? If we start here, then we're in the second quadrant, it will be somewhere like this, that we would have 132 degrees, okay? That means that the boat keeps on traveling north until it should have passed the lighthouse in order to have a bearing of 132 degrees, as you can see here, right? So maybe if I stop there, I'm gonna mark here the final position of the boat, and we could trace the bearing here. If we go north, then we're gonna go clockwise. Let me mark this here. We're gonna go clockwise until we get a bearing of 132 degrees. So maybe this is only a sketch, right? But it kind of replicates 132 degrees. Okay, so this is the correct sketch of the situation, right? This correctly describes the information that we're given in the problem. It says, later the captain observed that the bearing of the lighthouse is 132 degrees. How far did the ship travel between these two observations? So what are we looking for? We're looking for this distance over here. It's how far the ship traveled between the two observations. So I'm going to call this x. This is what I am looking for, right? X. Let me erase this. So now that we have done the sketch, we already know what to do. Okay, first thing I notice. The first thing I notice is that, for example, I can find this angle over here already, right? Because if this is 132, then the sum of this angle and this angle must be equal to 180 degrees, right? So I can find this angle here by completing the angle, right? Which should add up to 180 degrees. So I'm going to say that this angle must be 180. Let me do that here. 180 minus 132 degrees. And this is equal to 48 degrees. So this angle over here is 48 degrees. Okay, and now I see that I can apply sine rule, yes. Why? Because I have this angle and this side. So I have two pieces of information of the same letter, right? And then I also have this angle, and I could also find this angle now that I see, right? So with that information, I will be able to find x. So that's the easiest way. I can find this angle. As I already know this one and this one, I can do exactly the same thing we did here. We're going to say that we could call this angle L, right? Angle L is equal to 180 minus 48 plus 32. The sum of the interior angles is always equal to 180 degrees. So with this information, we can find the value of angle L, which would be equal to 100 degrees. 100 degrees. 48 plus 32, that's 90. No, that's 80, sorry. Yes, so angle L is 100 degrees. So once we know that this angle is 100 degrees, then we can easily find the value of x by applying sine rule, right? I'm going to turn back to red. So we're going to say that x is to sine of 100 degrees as, and maybe we can pick this pair as we already have angle inside. So we're going to say that as 10 is to sine of 48 degrees. So this is the sine rule applied to this problem, and we can solve for x. Leave the x alone, so this would be 10 times sine of 100 times sine of 100, and this is being divided by sine of 48 degrees. And then we find the value of x, which would be equal to, if we solve this using calculator, you're going to get a length of 13.25 kilometers. And this would be the final result for this exercise. So this is the answer. Okay. So how far did the ship travel between the two observations? It traveled this distance, which is 13.25 kilometers. Okay, so that's how we apply sine rule, and we combine with the concept of bearing. As I told you, the difficulty about this exercise is to actually do this sketch, interpreting the problem and doing the correct sketch. If you do the correct sketch, then solving the problem is actually very easy. Okay, so next class we're going to see something called the ambiguous case, which only applies to sine rule. We're going to see what that is about in the next class. So I hope this was clear, juniors. If not, please let me know. We're going to clear doubts in future live sessions. So thank you for your attention, and see you later.